Good afternoon and peace be with you. Today we're going to discuss about arithmetic series and geometric series for week 5 and 6. Arithmetic series or sum of arithmetic sequence. So our formula is S sub n is equal to n over 2 multiply a sub 1 plus a sub n. N is the number of term, a sub 1 is the first term, and a sub n is the last term. For example number 1, find the sum of the first 20 terms of the arithmetic sequence 15, 19, 23, 27, and so on. So for our solution, we're going to determine the 20th term to determine the last term. So let's identify a sub 1, which is 15, n is 20, and d is equal to the common difference, which is 19 minus 15 is 4. So to determine the value of a sub 20, we can use the formula a sub 1 plus quantity n minus 1 times d. So our a sub 1 is 15 plus our n is 20 minus 1 multiplied by the common difference of 4. Is equal to 15 plus 20 minus 1 is 19 times 4 is equal to 15 plus 19 times 4 is 76. Then 15 plus 76 is equal to 91. Therefore, our a sub 20 or the last term is 91. So to find the sum of the first 20 terms, so S sub n is equal to n over 2 multiplied a sub 1 plus a sub n. Our n is the number of terms, so 20 divided by 2. Multiply a sub 1 is 15, and the last term, which is the a sub 20, is 91. So we can now have 20 over 2 times 15 plus 91 is equal to 106. Let's divide 20 and 2. So the answer is 10 times 106. So 106 times 10 is equal to 1060. So our S sub 20 is 1060. Now let us proceed with example number 2. Find the sum of the first 10 terms of the arithmetic sequence if the first term is 3 and the 10th term is 39. For our solution, we already identified the first term, which is 3, and the 10th term is 39. So a sub 1 is equal to 3, a sub n is equal to 39. So we don't need to determine the 10th term because it is already given. So we are now proceed to the formula of the sum of the terms, which is S sub n is equal to n over 2 times a sub 1 plus a sub n. N is the number of term, which is 10. So 10 over 2 times a sub 1 is 3 and a sub n is 39. 10 divided by 2 is 5. Multiply 3 plus 39 is 42. So our S sub 10 is equal to 5 times 42, which is 210. Now, let us proceed with the sum of the finite and infinite geometric series. Geometric series is the same as the sum of geometric sequence. So let's start with case number 1. In this case, the common ratio is not equal to positive or negative 1. So for example, a finite geometric series 2, 4, 8, 16, 32. So this is a finite geometric series since we already have the last term, which is 32. So we're going to use this formula. S sub n is equal to a sub 1 quantity r raised to n minus 1 all over r minus 1. So we are now going to determine first the, the common ratio, which is r is equal to 2. Then use the formula. So S sub n is equal to our a sub 1 is 2, quantity, common ratio of 2, and number of terms. So our n is 1, 2, 3, 4, 5. So 2 raised to 5 minus 1 all over common ratio of 2 minus 1. Simplifying, so 2 times 2 raised to 5 is 32, or 2 times 2 times 2 times 2, 5 times, so the answer is 32 minus 1. All over 2 minus 1 is 1. Simplifying, 32, so copy 2, 32 minus 1 is 31. 2 times 31 all over 1, or 2 times 31 is 62. So our S sub n, or the sum of this sequence, is 32. If we're going to add 2 plus 4 plus 8 plus 16 plus 32, the answer is 62. And in this case, number 2, the common ratio is 1. And the given sequence is finite geometric sequence. So for example, 5, 5, 5, 5. So this is a finite geometric sequence with a common ratio of 1, since 5 divided by 5 is 1, and so on. So our solution will be S sub n is equal to n times a sub 1. So our n here is the number of terms. So we only have 1, 2, 3, 4, 5. So S sub n is equal to the number of term of 5 times a sub 1, 5. So our answer is 25. If we're going to add 5 plus 5 plus 5 plus 5 is 25. And in case number 3, r is equal to negative 1, or our common ratio is negative 1, and the finite geometric series. So we have two cases in this given, if n is even and n is odd. So let's first have the n is even. For example, negative 2, 2, negative 2, 2. So if we're going to observe, if we going to get the common ratio, it will be negative 1. And the number of term is 1, 2, 3, 4, even number. So our S sub n, or if we're going to add all the terms of the sequence, the answer is 0. Because negative 2 plus 2, 0. 2 plus negative, 0 plus negative 2 is negative 2, plus positive 2, the answer is 0. If the case is n is odd, so negative 2, 2, negative 2, 2, and negative 2. So our r is negative 1, since 2 divided by negative 2 is negative 1. And n is 1, 2, 3, 4, 5, which is 5. So if this case, S sub n will become a sub 1. So the value of a sub 1 is negative 2, so the answer is negative 2. Okay, let's proceed with case number 4. In this case, we have infinite geometric series, and the common ratio is greater negative 1 but less than 1. So most probably, the common ratio here are in the fraction or in decimal form. So let's have example 12, 6, 3, and so on. So in this case, the common ratio is 6 over 12 or 1 over 2. So we're going to use this formula. So S sub n is equal to a sub 1, which is 12, the first term, and 1 minus 1 half. So 12 all over 1 minus 1 half is 1 half. And dividing 12 and 1 half, the sum will become 24. Okay, so let's have the first given. Find the sum of the first 8 terms of the sequence 3, 6, 9, 12. So in this case, first identify the given sequence, whether it is geometric or arithmetic. So if we're going to observe 3, 6, 9, 12, we add 3 on the previous term. So therefore, this is an arithmetic sequence. So if we're going to find the sum of the first 8 terms of the arithmetic sequence, so again, we're going to determine first the 8th term or the last term. So a sub n is equal to a sub 1 plus n minus 1d. So let's identify a sub 1, which is 3, n, which is the number of term 8, and the common difference is 3. Then proceed with our solution. So a sub n is equal to a sub 1, 3 plus n is 8 minus 1 common difference of 3. Simplifying 3 plus 8 minus 1 is 7 times 3. So 3 plus 21 equals to 24. So our a sub 8 is 24. Then, since we already know the value of the last term, we can now determine the sum of the first 8 terms. So our solution or our formula is n over 2 times our quantity a sub 1 plus a sub n. So n is 8 over 2. A sub 1 is the first term plus the last term, which is 24. So simplify for 3 plus 24 is 27. So multiply 4 and 27. 4 times 27, the answer is 108. So let's see if we're correct. So answer is 108. Let's proceed with the second example. Find the sum of the first 12 terms of negative 6, 6, negative 6, 6. So we're going to observe this is a geometric series, or it's the geometric sequence. So, and let's identify the value of r. So r is equal to negative 1. And the number of term is 12. So according to our cases a while ago, if the common ratio is negative 1 and the number of term is 12 or even number, so to our S sub n will become 0. Since if we're going to add all the terms up to 12 terms, the answer will become 0. So let's check. So answer is 0. Number 3. Find the sum of the first 5 terms of 32, 64, 128, and so on. So, let's identify the value of common ratio. Common ratio here is 64 divided by 32 is 2. So, our common ratio is not equal to 1. So, therefore, we're going to use the solution on the case 1. Then, the number of term is 5. So, our formula in the case number 1 is S sub n is equal to a sub 1 times r raised to n minus 1 all over r minus 1. A sub 1 is 32, r is equal to 2, and the number of terms is 5 minus 1 all over r, which is 2 minus 1. Simplifying, so 32 times 2 raised to 5 is 32 minus 1 all over 2 minus 1 is 1. So 32 times 32 minus 1 is 31 all over 1, or we don't need to write 1. 32 times 31 is 992. So the answer is 992. Let's proceed with the example 4. Find the sum of the first 7 terms of 16, 32, and 64. So first, we're going to identify the common ratio. The common ratio is 32 divided by 16. So 32 divided by 16 is 2. Then the number of terms is 7. So the formula we're going to use is S sub n is equal to A sub 1 times R raised to n minus 1 all over R minus 1. A sub 1 is 16 times R, which is 2 raised to 7 minus 1 all over 2 minus 1, which is the common ratio. So simplifying, so 16 times 2 raised to 7 is 128 minus 1 all over 2 minus 1 is 1. So 16 times 128 minus 1 is 127 is equal to, we can now remove 1 since it's already denominator is 1. 16 times 127. So the answer is 2032. So let's check 2032. Now, find the sum of the first 20 terms of the sequence 4, 4, 4, 4. So this is a geometric sequence and our R is equal to 1 and our N is even number. So in this case, so first 20 even numbers, so our S sub N is equal to multiply the first term with the number of term. So the first term is 4 and the number of term is 20. So our answer is 20 times 4 is 80. Number 6, find the sum of 81, 27, 9, 3, and so on. So let's identify here the common ratio since the given is geometric sequence. So 27 all over 81 is equal to 1 over 3. Then, we don't have here the number of terms since it is a infinite geometric series. So our formula is S sub n is equal to A sub 1 all over 1 minus R. So A sub 1 is 81 all over 1 minus, common ratio is 1/3. So 81 all over 1 minus 1/3, 1 minus 1/3 is 2 over 3. 2 over 3. Therefore, 81 divided by 2 over 3 is equal to 243 all over 2. So our answer is